Alright guys, today 3.2 we're looking at solving systems of inequalities by graphing. So in lesson 3.1 we actually were solving systems algebraically and we weren't looking at necessarily inequalities. We were looking at solving systems of equations. So today a little bit different. We're just going to throw in the inequalities and we're going to graph those. So let's get right into it. So solving systems of inequalities. Step 1, we're going to graph the inequality, shading the correct area. Step 2, identify the region that is shaded for all the inequalities. What this means is we're going to have, if we have a system, you guys, system means that we're going to have more than one inequality. All right, the solution to both, which is the solution to the system, is the place where we have shading that is in both. So say I have a graph here, let's say one of our graphs looks like this, and another one, and we'll shade up here. We'll use the green. Okay, then we have another one, another inequality that looks like this, and its shading is up here. Okay, the part that we are concerned about today is the part that has both. Okay, so the answer to the inequality is actually the picture. It's the place where we have both the shadings. Okay, those are all the places on the graph that work for the system of inequalities. So we're gonna learn how to do that here with example 1. All right, so for example 1, I'm going to teach you guys a couple ways to graph these as well. So for this one, let's start with the y-intercept. Okay, so if the y-intercept's at 5, we put a point there, right? And then our slope is -2. Negative means going down from left to right. So I'm going to go down 2, careful this is going by 2s, down 2 over 1 and I'll be there. And then down 2 again over 1 and I'll be there. Down 2 again and over 1 and I'll be there. So I have that type of line. I look back here, I see that this has an or equal to, so this is a solid line. Okay, so I'm going to draw in the solid line. All right, and then I'm going to shade. So this is saying that y values are less than this line. So if they're less than, they're underneath. Okay, so it's going to be all of this stuff. All right, so that's my, this isn't perfect here, but that's my answer to the first part. Now let's go change colors here and go to the second part. So for the second one, my y-intercept is at -6. Okay, so -6. And then I am going to be going down 1 over 4. So if I go down 1 over 4, that's actually the same thing as going down 2 over 8. So I could do that as well. So I could go down 2 over 8 and be there. And I can go up 2, back 8, be over here. And this one is a dotted line because it's not or equal to. All right, so this one says that y values are, oops, I don't know what happened there. The y values are greater than that line. Okay, so since it's greater than, I'm going to shade above the line. So technically for this one, it's all of this area, okay? But the part that is our answer that we are concerned about is this area where we have the overlap. Okay, so when you're doing this, if you're doing this with a pencil, if you're doing it on an iPad, you can do something like mine where I can see the change in color. But if you're doing it in pencil, it should be very clear that there is overlap happening. So it should be really dark, a lot darker where you have the actual solution. Okay, so you got to get your shading correct. So that's example 1. Let's look at 1b. So for 1b, notice now we have an absolute value. All right, so here's where I'm going to teach you another way to graph. Even though you don't need it for this one, that's okay. So to graph this first one, we can always, you guys, let me go back here. You can always make an XY table to graph, right? So for this, I'm going to do that. If I plug in a, well, let's start with -2. If you plug a -2 in for x, take the absolute value of it, you get 2. Right? So if you plug a -1 in, you get 1. You plug a 0 in, you get 0. You plug a 1 in, you get 1. You plug a 2 in, you get 2. So if we graph that, -2, 2 is here, -1, 1 is here, 0, 0 is here, 1, 1 is here, 2, 2 is there. So you have something like that. I look back and I see that this is an or equal to, therefore it's going to be solid. Okay, so I'm just going to keep this pattern going. All right, so I got that thing happening. And then it says that the y values are greater than or equal to that. Okay, so I'm going to shade in above the absolute value equation because it's greater than that thing. All right, and then I'm going to go to my second line. And for this one, maybe I'll just do it the other way. So I'm going to start at 5, and then I'm going to be going up 4 over 3. Okay, I can also go down 4, back 3. So I'm going to go down 4, back 3, I'll be here. If I go up 4 over 3, I'm actually somewhere in there, I believe. 1, 2, 3, 4. Okay, so I've got that thing going on, and this is a dotted line. All right, and then on this one, it says the y values are less than this guy. Okay, so that means that it's going to be under the line. So I switch to highlight here. Okay, so technically that's my shading on that one, but the part that I'm concerned about is this part where we have overlap of the yellow and the red. All right, so that would be my solution. For example 2, on example 2 here, let's do this. Let's just go ahead and keep making our graphs. So we're going to start at positive 8 for that first one. We're going to go down 4 over 1, down 4 over 1, and we got this thing happening. This is a solid line. Okay, then we're going to start at 4, and we're going to go down 4 over 1, down 4 over 1, and we're going to up 4, back 1, and notice here, this one's a dotted line. Okay, slopes are the same, different y-intercepts. I know these are parallel lines. Let's do some shading. So on my first one, my shading was the y values were greater than that line. Okay, so that's over here. And then on my second one, it says the y values were less than. All right, so that would be this one, was less than. Okay, so for this one, like technically, you're still going to do all that shading for this one, but then, since we don't have any overlap on this one, remember that the solution to a system of inequalities is the place where we have overlap. So for this one, since the lines are parallel, and the shading are in the opposite directions, for this one, we have no solution. So you can actually write that on this one. This would be no solution. All right, and then we're going to keep cruising now. Let's look at another one where we may or may not have a no solution. I don't know. That might be what we're working on right now. Let's check it out. So for this one, this is y is greater than or equal to absolute value of x. Looks just like the one that we did before. So I kind of know what that one graphs like. Starts here. Okay, and we're going by tens on this one. So if I plug a negative 10 in, I get a positive 10 out. All right, so I got this V shape happening. It's just going by tens this time. This is a solid V shape. Right, and then for our other one, I have negative 24 somewhere in here. And then I'm going up 2 over 1, up 2 over 1. Since my scale is so big, I can also say that I'm going up by 20 over by 10. So if I wanted to do that, if I go up by 20 here, I'm at 4, and then over 10, I'm somewhere in here. Okay, up by 20, over by 10, somewhere in here. So I got a line that looks something like that. This line is going to be dotted. Okay, and then it says the y values on the first one are greater than the absolute value. So we're going to shade above. And then on my second one, it's less than the line. So we're shading below. My solution is up here where I have the overlap. All right, one more example, example 3, you guys. We're gonna do a word problem really quick. and then you guys will be on your own. So for this one, Mr. and Mrs. Rodriguez are driving across the country. Their children, they plan to drive a maximum of 10 hours a day. Mr. Rodriguez wants to drive at least 4 hours a day, but no more than 8 hours a day. And Ms. Rodriguez can drive in between 2 and 5 hours per day. Write and graph a system of inequalities for this information. All right, so this is an interesting problem. So we know that together, the two of them plan on driving 10 hours a day. So let's start with making an inequality about that. So Mr. and Mrs. Let's just call it R and S for Mr. and Mrs. So we can say that R plus S is going to be less than or equal to 10 hours. Okay, that represents both of them. Then let's focus on each one individually. It says Mr. wants to drive at least 4 hours a day, but no more than 8 hours. Okay, so to show that, I can just say he's going to drive between 4 and 8 hours. So 4, it says at least, so we'll say or equal to R, but he wants less than or equal to, so no more than 8 hours. So less than or equal to 8. So that's the inequality for Mr. And then we'll do Mrs. So for Mrs., she says she wants to drive between 2 and 5. Okay, so for 2 and 5, we can do this. I'm guessing she could drive. Doesn't really specify. I'd be okay with either solid or dotted lines for these because it says between 2 and 5. Doesn't say or equal to, but I'm kind of guessing that. So either way is fine. I'm going to put or equal to because I'm assuming she could drive 2 or 5 hours. So here are the three inequalities. Now the key to this one is to graph these, all right? So we got to graph them because it's the picture that is the answer. Okay, so if we do that, for the first one, we need to create a line. So we got to first define, which one's Mr., which one's Mrs. We can call this one Mr., call this one Mrs. Okay, so if Mr. is the Y, then we can solve the first one for R, right? So I'm going to take this first inequality and I'll bring it down here and I'm going to solve it for R. So R is less than or equal to negative S, I just moved the S to the other side, plus 10. So at plus 10 we have a point, and then we're going down 1 over 1, down 1 over 1, down 1 over 1. Okay, so we have this line happening here. Okay, so that's the first one, and it's solid. Okay, and then it says it's going to be less than or equal to that line. Okay, so I'm going to just shade here underneath the line. All right, so far those are all my possibilities, but I got to put the other ones in. So then for my second one, it says it's between 4 and 8. So really, it's two separate things that I have to be concerned with when I'm drawing the line here. I have to look at this part of the problem, and then I have to look at this part of the problem. Okay, so the R values are greater than or equal to 4. Okay, so I can draw a line at 4. Okay, and this is the R value, so this is on the Y, right? So Y is equal to 4. So I have that line happening, and then I also have R is less than 8. Okay, so if I were to shade here, well, let's shade both of these at the same time. So let me do this. R is less than 8. Okay, so it's less than 8, greater than 4. So the shading would be between this, right? So now we've narrowed our solutions to everything that's in this area. All right, where we have the double overlap. But now we still have misses to do. So let's bring that one in. So for this one, we would have 2 is less than or equal to S, and we also have S is less than or equal to 5. Okay, so let's go ahead and put those, and these are going to be the X values because this misses is in the X direction. Okay, so I'm going to change colors here to blue now. So we have 1 at 2. That's a straight line, believe it or not. And then we have 1 at 5. Okay, and if we're talking about X values here that are where the S values are bigger than 2, then we're going to go this way from 2, but less than 5, we're going to go this way. So it's in between. So all the shading for this happens in between. Okay. And now the tricky part is the solution. So I'm going to do this in blue just so you can see it if you don't see it already. But the only place where you have overlap of all 3 colors is right here in blue. So that would be your solution to this problem. That's kind of a tricky one. You'll have one like that on the homework, but just kind of attack it in the same way, and you guys should be fine. We'll